In this video, I will show you how to graph a parabola with vertex at the origin, even if the parabola is sideways. Now, back in the day, you learned to graph the equation y equals x squared, all right, in earlier class, probably Algebra 1. And we found that the graph looks something basically like this. All right, if this is my x and y axis, y equals x squared was a parabola, and it would be upward facing like this. Now, of course, if we had y equals negative x squared, the effect of that was that the parabola turned upside down. All right, so we would have a parabola, but it would be downward facing like this. Okay, so hopefully you understand that if you saw an equation that was written backwards, like x squared is equal to y, this is still the same thing. Okay, or if I had x squared is equal to negative y. These are no different. So in the unit that we will be working on now, we will tend to put the squared term first. So instead of having y equals x squared, you will see x squared equals y. But still picture your usual everyday parabolas. However, what if you had, instead of y equals x squared, okay, like normal, what if you had x equals y squared? What's happening now? Well, the deal here would be that this is a sideways parabola. Okay, x equals y squared is still going to be a parabola, but it will be opening to the right like this. All right, in this unit, we're going to have to deal with parabolas like this. And in the same way, if I had x equals negative y squared, that would be a parabola opening to the left. Okay, now in this unit, again, the squared term will be written first in almost all cases. So you will see something like this, y squared is equal to x. But still, as soon as you see that y term being squared, you know it will be a sideways parabola. All right, and the equation for this, in this unit, it will be written more like this, y squared equals negative x. So, in short, if the x is squared like usual, then it's going to be opening up or opening down like usual. But if the y is squared, which is weird, that tells you it will be sideways. If it's positive, it'll be to the right. If it's negative, it'll be to the left. So for these first few problems, we just need to say whether the parabola opens up, down, left, or right. Again, remember that an equation that is like y equals x squared, this was sort of normal. And if you see one that's more like x equals y squared, that would be very strange. Okay, so look at this one. This is like x equals y squared. This is one of the weird ones. So that tells us that it will be sideways. It will either open left or right. Because it's positive, it will open to the right. Okay, it would be a parabola like this. This one, if I sort of ignore the 8 for a minute, I have y equals x squared. That's good old normal y equals x squared. So this will be opening either up or down, like normal. Because everything is positive, I know it will be up. Looking at number 3. Okay, I have x equals y squared. That's weird. That's not what we used to have. This must be sideways. Because of the negative, I know that it will be facing to the left, like this. This one, y equals x squared. That's normal. So I know it will be up or down. Because of the negative, I know it will be down. Like this. All right, for the next few problems, we're going to be a lot more specific. We know right away that the vertex is going to be at 0, 0. If the vertex were something else, we would have other values added or subtracted. For example, if I had y minus 5 squared is equal to 8 times x plus 1. Now this would be a parabola that has a vertex of -1, 5. We'll talk about that more later. If you don't see any extra values being added or subtracted, there's no parentheses, then you know that the vertex will be 0, 0. Okay, so the vertex is 0, 0. Now, this number that's right here, it is something called the focal width. That means it's the width of the parabola at the focus. Now, this means that 4p is equal to 8. This number right here is always 4 times the p value. So that means that if I divide both sides by 4, I discover that p is equal to 2. Now, what does that tell me? P is the distance from the vertex to the focus. Okay, now, is this parabola opening up, down, left, or right? This is one of those weird ones where we have the y squared. This is sideways. So everything is positive, so I know this will be opening to the right like this. So that tells me that when I place my focus, I'm going to take the p value and I will go to the right by that amount. If the parabola was opening up, I would have put my focus up. Now basically the parabola is going to be wrapped around the focus. Okay, the focus is always going to be in the interior of the parabola. So I know that this is what's happening. But I need to be more specific than that. I'm going to use my focal width of 8. So I know that at the focus, the parabola has a width of 8. So that's why I'm going to go up 4 and down 4. All right, for a total width of 8. So these 3 points really show me where the parabola is going to be. So I will go ahead and draw my parabola, being careful to hit these 3 points. Okay, I'm hitting the focal width and the vertex. Now, there's something called the directrix, that is P to the left. It's a line, a straight line. So if the parabola is opening to the right, the directrix will be vertical. It's like this. This is called the directrix. Okay, understand that if the parabola had been opening up, the directrix would be down here. If the parabola were opening down, the directrix would be right here. If the parabola were opening to the left, the directrix would be on the right. Okay, so this directrix is a vertical line at -2. So the equation will be x equals -2. Every vertical line has the equation x equals something. The p value was 2. All right, we found that at the beginning, so I'm just going to fill that in. The focal width was the 8. So we knew that from the beginning. We know the focus because we went p to the right, and there it is. So this is the point 2, 0. So the focus is 2, 0. And that is how you graph a parabola in some detail. Okay, let's take a look at number 6. First of all, is this parabola going to be up, down, left, or right? Well, ignoring the 12 for a second, this is like y equals x squared. That's a normal up and down parabola, like we're used to. Because of the negative sign, I know that this is going to be a downward facing parabola like this. So here's the big picture. I'm looking for a downward facing parabola, which means the directrix should be like this. Okay, so let's make a graph like this appear right here. So we know that the vertex will be 0, 0. Nothing is being added or subtracted. Okay, so the vertex is 0, 0. All right, this 12 is the focal width. All right, it's the width of the parabola at the focus. The focal width is always positive, so I just ignore that negative sign. The focal width is 12. Now the focal width is 4p. So 4p is equal to this negative 12. Dividing by 4 gives me p equals negative 3. Okay, so that tells me that the focus is going to be 3 down from the vertex. So my focus is going to be right here. Okay, there's the negative 3. All right, again, I knew right from the beginning that I'd have a parabola opening downward. And the focus, I know, will be in the interior of the parabola. So keeping that in mind helps me make sure I go in the right direction for my focus. This is the point 0, negative 3. So my focus is at 0, negative 3. The p-value was negative 3. Okay. Let's go ahead and use the focal width of 12. So I know the parabola is opening this way. Here's the focus. The width has to be 12. So that means if I go 6 to the right and 6 to the left, then I have a focal width of 12. So this shows me that my parabola is going to pass through these points like this. Okay, now my directrix I know is going to be horizontal. It's going to be p in the other direction. So if here I have a negative 3, then my directrix will be at positive 3. So this is my directrix. Horizontal lines are always y equals something. So this is y equals 3. I was supposed to circle horizontal, and then this one was vertical. Okay, and that's it. That's it for number 6. Let's take a look at number 7. First of all, will this be up, down, left, or right? Ignoring the negative 16 for a minute, I have x equals y squared. That's not normal. The normal equation was y equals x squared, not x equals y squared. So this is going to be sideways. Because of the negative, I know it's going to be sideways opening to the left. Okay, so I know this is the big picture. It will be opening to the left, which means I will have my focus will be in the interior and my directrix will be vertical. Okay, so let's get started. So once again, my vertex is at 0, 0. There's nothing being added or subtracted. I know it's going to be opening to the left. My focal width is right here. Okay, my focal width is 16, positive 16. Focal width is always positive. Now, I'm going to take this number, though. This is 4p. So 4p is equal to negative 16. Dividing by 4, that tells me that P is equal to negative 4. This tells me where to put the focus. Okay, I know that the focus should be to the left of the vertex, and now I know that it will be negative 4. So this will be my focus right here, which, by the way, tells me that my directrix will be 4 in the other direction. So this is my directrix right here, just like we visualized. Okay, now let's use the focal width to plot 2 more points. Since the focal width is 16, positive 16, that means the width of the parabola at the focus is 16. So if I go up 8 and down 8, that's going to be a total width of 16. So basically I can now see how my parabola is going to go. Okay, something like that. All right, let's fill in everything. So the directrix is vertical with the equation x equals, all right, a vertical line is always x equals something. In this case, x equals 4. My vertex was 0, 0. My p-value was negative 4. My focus is here at negative 4, 0. All right, and I think that's it for problem number 7. All right, let's do one more on this video. Now, if I ignore the 2, I've got y equals x squared. That's normal. So I know that this will either be opening up or down. Because everything is positive, I know that this will be opening upward, which means I'll have a focus in the interior and a directrix that is horizontal. So I'm going to get a graph that looks like this, but let's graph in detail. Now in this unit, we usually put the squared term first. So this is the same as writing x squared is equal to 2y. Now this 2 tells me a couple of things. This is the focal width, which is always positive, all right, but the focal width is going to be 2. But also, I know that 4p is equal to this number. So 4p equals 2. If I divide by 4 on both sides, I get p is equal to 2 over 4, which means that p is equal to 1/2. This 1/2 tells me where to put the focus. Now, the vertex is still at 0, 0. There's nothing being added or subtracted here, so 0, 0. Now, I already know that my focus should be up from the vertex. But now I know that it's going to be up half of a unit, half of a square. So this is going to be really small, but my focus should be right here. All right, almost on top of my vertex. My directrix should be a horizontal line that is down half a square. So it's going to be right here going through the middle of these squares. Okay, horizontal lines are always y equals something. This is y equals negative 1/2 because it's down half a square. The focus here is 0, 1/2. Okay, let's use the focal width. The focal width, remember, is 2. That means that at the focus, my parabola has a width of 2, total width of 2. That means 1 to the left and 1 to the right. So this is really tight, but this is how my parabola is going to look. All right, we're just going to use these 3 points that we've got and make the best of it. Okay, and that's it. Let's write everything down that we have. So the directrix was y equals -1/2. The vertex was 0, 0. The p-value was 1/2. The focus was 0, 1/2. And that's it. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.